Hi, I'm Dr. Steve Yamamoto, CEO of Matrix Sensors. We are a deep tech startup based in San Diego, California, and we are focused on developing a new class of gas sensors on a chip. Our first product is a low-cost, low-maintenance carbon dioxide sensor for monitoring indoor air quality. Our core technology is based on a revolutionary new class of sensing material known as a metal organic framework, or MOF. Here at Matrix, we have a team of 15 chemists and engineers focused on bringing our MOF sensor technology to market. If you Google CO2 sensors, you'll find that there are several available on the market today. They are all based on the same decades-old technology, which is infrared absorption. These sensors tend to be expensive, over $100 in low volumes and maybe $20 in very high volumes. But the biggest drawback is that these infrared sensors, like all optical devices, drift over time. This means that someone has to touch the sensor to do a manual calibration every 6 months. This is the problem that we are solving at Matrix. Our value proposition is simple. Just install the sensor and forget about it. Why is this such a big deal? The answer is energy efficiency. A reliable CO2 sensor will enable building owners to control HVAC systems based on CO2 levels, and this avoids overventilation. The DOE estimates that this can lead to an energy savings of up to 30%. So how do you measure CO2 on a chip? Well, if you think about it hard enough, you'll very quickly come to the conclusion that you need a sensing material, a material that absorbs CO2 but doesn't absorb anything else. It turns out that this is much harder than it sounds and really wasn't possible until very recently with the invention of metal organic frameworks. It turns out that these materials can be tuned to absorb specific molecules, making them the ideal material to enable a solid-state gas sensor. Our sensor architecture is straightforward. It consists of an engineered MOF thin film on a quartz resonator, which we use as a mass transducer. It's a simple measurement. When CO2 levels rise, gas enters into the MOF, and the resulting mass change is measured as a frequency shift of the quartz.
Hi, I'm Dr. Jessica Morton. I'm a senior scientist here at Matrix Sensors, and I'm here to talk to you today about metal organic frameworks, or MOFs. In its most basic sense, a MOF is a super efficient sponge for gases or liquids. A MOF is metal nodes connected by organic linkers in regular, repeating, crystalline frameworks. These frameworks have identical and permanent open spaces throughout them called pores. These pores are generally very, very small, but they're just large enough to allow gas and liquid molecules to come and go. The exact size, shape, and chemistry of a MOF pore is determined by the metal and the linker used. Thousands of MOFs exist today because of the large variety of metals and linkers we have available to us, so we can select the right pore environment for sensing the right gas for our sensor.
Our first product targets CO2 sensors for energy-efficient HVAC control in commercial buildings. But the overall market for monitoring indoor air quality is much larger and includes home applications in IoT devices such as Google Home and Amazon Alexa, and automotive, where people would like to monitor air quality for comfort and safety in cars and trucks. Our technology is also a platform technology, in that we can enable other types of gas sensors such as methane by engineering a different MOF and leveraging the same sensor package in electronics. Our leadership team has over 40 years of experience in sensor systems and companies including Qualcomm, Life Technologies, and KLA. We also have several PhDs, including world-class MOF chemists. In addition, we have a deep bench of advisors, including MOF pioneer, Professor Omar Yaghi from UC Berkeley. We are fortunate to have TDK Corporation as a commercialization partner. TDK is a world leader in sensor components and an equity investor in Matrix Sensors. We also have a formal joint development agreement in place where we are working together to develop a product prototype. We also have a financial partner called Mark IV Capital. Mark IV is a real estate investment firm with a strategic interest in advanced building technologies. They intend to provide a 20% cost share should we win this award. As a deep tech hardware startup focused on commercializing a new material, it's very difficult to raise sufficient private funds in this country to scale our manufacturing. Without ARPA-E scale-up funding, we would likely need to look overseas, where it's well known that investors have a larger appetite to fund deep tech hardware ventures like ours, which is an option that we would like to avoid with the help of scale-up funding. Thank you for the opportunity to submit this proposal. This grant will help us take Matrix Sensors to the next level.